Hello, hello. Am I audible to you?
Yes, ma'am.
Ma'am.
Yes, ma'am.
Yes, ma'am.
So today, in this lecture, we are going to start with unit number 3, that is set theory. Unit number 2, we will see later after completion of this unit. Okay. So first of all, we have to say what is the syllabus for this chapter. In this chapter, we are going to cover the basic concepts of set theory, types of operations, those we can perform on sets. Then we have to see concept of order pair, and next one is Cartesian product. Again, same book you have to refer for this unit also. That is written by J.P. Trimble and R. Manohar. So these are the MCQs and assignment questions. So after completion of this chapter, you have to complete this one, assignment questions and MCQs. Have you written assignment number 1? Have you started it, which is based on unit number 1? If you have not yet started, you have to start it. Within 1 week, you have to complete assignment number 1. Questions are already given to you. Okay. Now next one is about title of chapter. So this chapter, that is set theory, includes all the information related to sets, like what is the set, what are the basic operations on set, Cartesian product and ordered pair. Then what is the central idea of chapter? So this chapter is based on set theory, so it deals with definition, operations and representation of sets. It also gives an idea about order pairs and Cartesian products. Next point is importance of chapter in subject. This chapter has considerably weightage in syllabus of subject. It helpful to develop more logic amongst the students. That's why this chapter is important. Now we have to see what are the objectives and outcomes. Objective number 1, to introduce the basic concepts of set theory. Second objective, to provide the knowledge about operations on sets. Third one, to provide knowledge of order pair and Cartesian product. Now, next point is chapter outcome, that what student will be able to do after completion of this chapter. So, first outcome is explain basic concepts of set theory. Second one, apply different operations on set. Third one, apply Cartesian product on two sets. And fourth one, explain the concept of order pair. Now we are going to start the actual syllabus. So first point is definition of set. So how we can define this set? So set means collection of objects of any sort. So here we can say that set is a collection of objects of similar type. Okay. For example, we can consider set of all books. So why this one is called as set? Because it is containing number of objects or multiple objects of same type. So here that object is book. So collection of book we can call that one as a set. Consider second example, a pair of shoes. Pair means what? It will contain two shoes. Okay. So again this shoe is of one category and here are two different objects of same kind. That's why this one is also called as set. Now if you consider the bouquet, that bouquet also contains multiple flowers. But all those are belongs to one category and that category is flower. That's why all these are examples of sets. So set is defined as collection of objects of any sort or collection of objects of any kind. Okay. So have you understood what is meaning of set? Hello? Hello? have you understood what is meaning of set?
Yes, ma'am.
Okay. So now we have to see the next point as how we can define the membership of this set. So any object belong to a set is called as member or element of that set. So if any element is belong to or any object is belong to that set, then that object is called as member of that set or element of that set. Again, a set is said to be well defined if it is possible to determine by means of certain rules whether any given object is a member of that set or not. So here they have given definition for well-defined set. So set is called as well-defined if it is possible to determine whether any object belongs to that set or not. Then only that set is called as well-defined. So here some conventions are given. So capital letters will be used throughout to denote the set. So keep in mind that capital letters will denote set. Okay. And lowercase letters will use to denote elements. So here we are going to use the conventions. Capital letters for sets and lowercase letters or small letters for members. So by using this symbol belongs to. So P is a member of that set. That's why this is in lowercase. A is a set. That's why it is in capital. So P belongs to A. Or we can say that P is a member of A. Or we can say that P is in A. So meaning of this symbol is same. P belongs to A or P is a member of A or P is in A. Okay. So this denotes that P is a member and A is a set. Okay. Now this is for belongs to concept. Now suppose there is any another object. Suppose that object is Q and which does not belong to set A. Then how we can express it? So Q does not belong to A. So this is the symbol for does not belong to any set, and this is for belongs to. Okay. So again, Q is a, we are going to consider Q as a member. That's why this is a in lowercase. A is a set. That's why it is A. Now capital letter, that is A. Now we can express Q does not belong to A as negation of Q is in A. Okay. So this is correct. If you take negation of Q belongs to A, it will give you Q does not belong to A. So this can be written as negation of Q belong to A. This is equivalent to Q does not belong to A. Here one example is given. Suppose set S is given. So this set S is in capital because this is a set and all these are the members. Those are included in this parenthesis as 1, 3 and A. So here we can say that 1 is member of S or 1 belongs to S, and that is written here as 1 belongs to S because 1 is present in this set S. Again 3 belongs to S because 3 is also included here. Last element is A, so A also belongs to S. But if you find 2 is not here, so how we can express it? 2 does not belong to S. So this is the symbol for it does not belong to. So 2 is a not member of this given set. So that is expressed here as 2 does not belong to S. Okay. So this is the concept of membership of set. Okay. So suppose A. So here we can give that x will belong to the set if x is equals to 1 or x is equals to 3 or x is equals to 8. So this predicate will define set 1, 3 and 8. Okay. Again, these sets can be finite or infinite. So when we are going to say set is finite, that if number of distinct elements present in a set is finite, then we are going to say that that set is finite. If the number of elements those belongs to sets are infinite, then we are going to say that that set is infinite. Okay. Now here again one example is given for set S, and that is containing elements. First element is A, second element is again set, and that set is containing two elements 1 and 2. Third one is P, and last one is set Q. Okay. So there are total 1, 2, 3, 4. So 4 elements are here in this set S. Okay. So here set Q is an element of S because this set Q is present in S. That's why this set Q is an element of S. But if you consider just element Q, that element Q will not be an element of set S, but it is a element of this set Q. So why that Q is not a member of S? Because check here whether we have written just Q, only Q here in this set. No, one element is there, but it is containing parenthesis. So what is meaning of this parenthesis? This defines set. This one, that is a set Q. But only Q is not here. That's why Q is not a member of this set S. But if you consider set Q S, that set Q is member of S. So are you getting this? Why Q is not member of S? Hello? Hello?
Yes, ma'am.
Are you getting it? Why Q is not member of S?
Yes, ma'am.
So can anybody explain why Q is not member of S?
Explain again, ma'am.
That's why I am asking. If you are not getting anything, please ask me. I will explain it once again. Okay, fine. So here, look at this set S. So this set S is containing elements. First element is A. Second element is again set. And that set is containing elements 1 and 2. So this is the second element of set S. Now third element is P and last element is set Q. Okay. So there are total 4 elements in this set S. Okay. Now they have asked you a question whether Q is a member of this set S. Just Q without any parenthesis. Now check here whether such element is here. No, one Q is present, but that is containing parenthesis. So what is meaning of this parenthesis? It defines here that Q is a set Q. So set Q is there in this set S, but only Q is not here. That's why Q is not a element of set S. But if you consider set Q is here, that's why set Q is a member of set S. So if you consider this set Q, we can say that Q is a member of set Q but not a set S. So again I am repeating here, Q is a member of this set Q but not set S. Now, have you understood? Hello? Okay.
Yes, ma'am.
Now, next point we will see is inclusion and equality of sets. So, what is the concept of inclusion? Let A and B be any two sets if every element of A is an element of B, then A is called a subset of B, or A is said to be included in B, or B includes A. So three terms are there. Here we are going to check the concept of subset. So when we are going to say one set is subset of another set, consider there are two different sets A and B, and if every element of A is an element of B, then we are going to say A is subset of B, or we can say that B includes A. Okay, and this subset is denoted by this symbol. So here A is subset of B, so that is written here. And otherwise, in second option, we can say that B includes A. So this is the symbol for inclusion. B includes A, and this is for subset. A is subset of B. So here we can define that subset as A is subset of B. This is equivalent to for any element X. If X belongs to A, then X belongs to B. And this is equivalent to B includes A. Why this is so? Because we are going to say A is subset of B if and only if all the elements of A are in B. Okay. So if that element is in A, then it must be in B. So if X belongs to A, then X belongs to B. So this is the concept of subset or inclusion. Now here, check four sets are given. Set A is containing 1, 2, 3. B is containing 2 elements 1 and 2. C 1 and 3. D is only 3. Okay. Now here we can say that B is a subset of A. Why? Because all the elements of B are in A. Now check. B is just containing elements 1 and 2, and these two elements are present in A. That's why B is subset of A. So again, if you check here, set C, it is containing two elements 1 and 3. Again, those two elements are present in A. That's why C is subset of A. So again, here we can say that D is subset of A. So again, we can say D is subset of another set. Can you tell me which one is that set? D is subset of A. Yes, that is correct. There is another option for which set D is subset. Just you have to check whether 3 is written. Yes, D is subset of 3. Oh, sorry, C. Because 3 is a element of this set D, and that is present in this set C as well as A. So B is subset of A and C. Now here again just we have taken here elements. Now next example. Now suppose set A is containing elements. First element is set 1, second one is 2 and third one is 3. Okay. Then here we can say that set 1 is member of A. So why I have written here member of A? Yes, because this set 1 belongs to set A, that is present in set A. That's why set 1 belongs to A. Now, if you take subset of these two, here set 1 and 2. So these are included in one set. That's why we are going to say this one is subset of A, because these two elements are present in A. That's why it is a subset. Why this one is called as subset? Because we have included these two elements in a parenthesis. And what is meaning of that parenthesis? It is a set. So this one is a subset of A. So again, if you take this set 1 into parenthesis, means what? Again, this becomes a subset. So this one is again subset of A, as that element set 1 is present in A. So again, if you consider 2, if you give parenthesis to this 2, means what? This is subset of A. So if you just write 2 here, so what is meaning of 2? If you don't give parenthesis to 2, means what? It is a member of A. So that membership is written here as 2 belongs to A. Okay. Again, if you consider this 2 and 3, and those are included in parenthesis, means what? It is a subset of A. So, have you understood this concept? Subset and belongs to? Hello? Hello? Any doubt regarding this point? Membership or
Yes, ma'am.
subset? If you are not getting anything, please ask me again. हे समझ का? हे असंच का लिहिलं? These conventions are very important. We are going to use this throughout the chapter. Have you understood? Okay. So here I am going to ask you one question. 1 belongs to A. You have to tell me whether this statement is true or false. 1 belongs to A.
False.
True or false? False. Why false?
False.
Yes, that answer is correct. But I want explanation. Why this one is false?
In set A, 1 is not contained. This set A is set 1 is present.
Set 1 is present, but just 1 is not there. Yes, that explanation is correct. That's why 1 does not belong to A. Good. Now, next one is properties of set inclusion. So, every set is subset of itself. So, A is subset of A. So, keeping this in mind that every set is subset of itself, and this property is called as reflexive. Okay. Again, A is subset of B and B is subset of C, then A is called as subset of C. So this property is called as transitivity. So this inclusion satisfies two properties. First one is reflexive and second one is transitive. So next definition is for equality. So when we are going to call two sets are equal. So definition is given here. Two sets A and B are said to be equal if and only if A is subset of B and B is subset of A. So this is very important. So if there are two different sets A and B, then they are going to say A and B are equal if and only if A is subset of B. So what is meaning of this statement? A is subset of B means all the elements of A are in B. Okay, that we have seen earlier. No. And second one is B is subset of A. Means what? All the elements of B are in A. So what is meaning of these two conditions? A is subset of B and B is subset of A. Means what? These two sets are equal. So symbolically we can represent as A is equals to B, this is equivalent to A is subset of B and B is subset of A. So this is the concept of equality. So here we can say that A is equals to B. This is equivalent to for any element X, if X is belongs to A, then X is belongs to B. Or if X is belongs to A, if and only if X is belongs to B, then only we can say that these two sets are equal. Now here some examples are given. From this we have to identify whether first set is equals to second. Now first set is containing three elements as 1, 2 and 4. And second set is containing four elements as 1, 2, 2, 4. Now we have to check whether these two sets are equal. So I want to answer from you whether these two sets are equal. Apply the definition. Check whether A is subset of B and B is subset of A.
Yes, ma'am.
Yes, these two sets are equal because here first set is containing elements 1, 2 and 4. So if you consider this set as A, all the elements of A are in B. That's why we can say that A is subset of B. Now, again, if you consider this element, this set B, it is again containing elements 1, 2, 2, 4. So, all the elements of set B are in set A. That's why B is subset of A. So, it satisfies both the conditions. A is subset of B and B is subset of A. That's why these two sets are equal. Now, in second example, it is containing elements 1, 4, 2 and second set containing elements 1, 2, 4. So just sequence is altered, so no matter. So these two sets are equal. Now, third example is any doubt? Now, third one. Here, P is containing elements. First element is set 1, 2 and next element is 4. And Q is containing elements 1, 2, 4. So here these two sets are not equal. Why? Because this is set 1, 2. But if you consider here 1 and 2 are separate members. But here those two are included in one set. That's why P and Q are not same. Are you getting it? Why P and Q are not equal?
Yes, ma'am.
Okay. Now, next one, set of set 1 is not equals to set 1. This concept we have seen earlier, because here set 1, this is member of this whole set. So set 1 belongs to set of set 1. And if you consider just set 1, then 1 is member of this set. So these two statements are not equal. Again, if A is equals to, for any element x, x into x minus 1, that is equals to 0. This is defined as set A, and B is given as 0 and 1. Then we have to find out whether these two sets are equal. So first we are going to consider the value for this x as 0. Now put this value here, that is 0 into 0 minus Hello? Hello?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
हा कुठेपर्यंत होतं पण युनिव्हर्सल सेटची डेफिनेशन बघितली का? हॅलो? Have you seen this definition for universal set?
No, ma'am.
Okay.
Screen is not visible.
Now check. Is it visible?
Yes, ma'am. Visible.
Okay. So here, next definition is for universal set. So what is meaning of this universal set? A set is called as universal set if it includes every set under discussion. A universal set will be denoted by the symbol capital E. So capital E is equals to for any element x such that P of x or negation of P of x, where P of x is any predicate. Now we have to see what is meaning of this universal set. The set which is containing all the elements, those belongs to any particular set as well as those does not belong to that set is called as universal set. If you consider any set A, then the elements those belong to set A as well as those does not belong to set A will be included in this universal set, and that is represented by E. Now a set, next concept is for empty set. A set which does not contain any element is called as empty set or null set. Empty means what? A set which does not contain any element, and that empty set is denoted by phi. So that is defined here. Phi is equals to for any element x, p of x and negation of p of x. So why this symbol is conjunction here or and here? Because what is meaning of this line? Any element which belong to set as well as does not belong to set. So is it possible एक एलिमेंट आहे तो सेट मध्ये आहे पण आणि नाहीये पण? No, that condition will never true. That's why that is written by phi. That is empty set. There will not be such an element. Okay. Now take here definition of these two. First one is for universal set. So for universal set, we have to include all the elements. That's why here that symbol is or disjunction. But if you consider empty set, that symbol is conjunction. Okay. Now next definition is for power set. So for set A, collection or family of all subsets of A is called as power set of A, and that power set is called as or denoted as P of A or 2 raised to A. So what is meaning of this power set? So collection of all the subsets is called as power set. Now, power set of A is equals to 2 raised to A, where A denotes the number of elements in set A. So, here that is equals to for any element x such that x is subset of A. So why we have taken here subset? Because definition for power set is collection of subsets. So this X here represents subset. So we have to find out all such a collections. That's why X is subset of A. Here we have to define some power sets. So what is the power set of phi? Phi means what? Empty set. And here the only one element is there. That's why phi. So power set of phi is always phi. Now, if we consider the next set, that set is containing one element as A. Then we have to find out what would be the power set of S1. So here we have to find out using this formula 2 raised to A. Now here in this set there is just one element, that is A. So 2 raised to 1 means what? There would be two elements in power set of S1, and those elements are phi, and next one is set A. So this is called as power set of S1. Keep in mind that phi is always first element of any power set. So you have to must include phi as a first element of power set, then remaining elements. Now, if S2 is given as set A comma B, then power set of S2 will have total 4 elements. So how we have identified that? Because S2 is containing 2 elements, so 2 raised to 2, that is equals to 4. So in the power set, 4 elements would be there. As we have seen, phi is the first element of every power set of any set. That's why phi is the first element. Then set A, this is the second element. Then set B is the third element. And then set A comma B, or we can directly write that one as S2, is the last element. Now, if your S2 is containing 3 elements, then how many elements would be there in power set of S3?
8 elements.
8 elements, correct. Because that formula is 2 raised to 3, that is equals to 8. Again, first element is phi, second element is set A, then third element is set B, then next element is set C, again next element is set A comma B, then set B comma C, then set A comma C, and last one is set A B C, and that can be written as S3. So there would be total 8 elements. Have you understood what is the concept of power set? Hello? Have you understood what is the concept of power set?
Yes, ma'am.
Okay. So just we will revise what we have seen. So in this chapter, we have seen first point is set. So can you tell me what is meaning of set? Set means what? Collection of objects of similar type or similar kind is called as set. Then we have seen what is the concept of membership and belongs to. Then next definition we have seen for inclusion. So what is the meaning of subset? So if there are two different sets A and B, then A is called as subset of B if every element of A is in B. Next one is for equality. If there are two different sets A and B, then we are going to say A is equals to B if A is subset of B and B is subset of A. Next definition is for proper subset. If A is subset of B and A is not equals to B, then we are going to say A is proper subset of B. Now next definition is for universal set. So all the elements or all the objects under discussion constitute universal set, and that is represented by capital E. Empty set, that is denoted by phi, means what? A set which does not contain any element, that is called as empty set. And last definition is for power set. So power set is a collection of all the subsets, and that is represented by P of A or 2 raised to A, where A represents number of elements in set A. So have you understood today's concepts? Okay.
Yes, ma'am.
Yes,
So
ma'am.
we are going to stop here. Just give me your presentee. Roll number 1. I think only 35 students are here. Okay. Present numbers. Give me your roll numbers.
6, ma'am.
6.
9.
Okay.
4.
17.
17.
15.
Okay.
26.
32.
36.
32.
32.
26.
48.
85. 26.
28. 69. 28.
25.